density of fluid is not constant in fluid flow. So rho equal to not equal to constant. Understands? So d rho equal to dp with respect to pressure not equal to 0. But number 6, incompressible flow is that is constant in a flow. So this is equal to constant, so this value is 0. Density with respect to pressure, this is pressure and this is 0. Understands? Types of flow. Next is acceleration of fluid particles. Acceleration. No, first velocity is the u vector v equal to I cap and k cap. So change in velocity dv equal to change in velocity du by dx into dx plus change du dv, sorry, this will not dv du, changing this vector, sorry, dv equal to dy into dy, this change and d omega into dz into dz. So acceleration equal to dv by dt. So acceleration equal to dv by dt equal to this du by dx equal to u plus this is dy by dt equal to v dv into dy, and d by the omega into dz plus dv by dt, and this portion is convective acceleration. And this is the temporary or local acceleration. Understand? Now acceleration in x direction equal to du by dx, and v equal to du by dy plus du by dz by du by dt. In similar case, same case, acceleration in acceleration along y direction. Acceleration along y direction equal to u into dv, u, sorry, this is v plus v into dv into dy plus omega dv into dz plus dv into dt. Understand? And this one is same du omega into dx, this plus v equal to d into dy omega w equal to dw and dz plus d equal to dt. So acceleration of fluid particle is root over ax whole square plus ay whole square plus this, and this is whole square. Understands? This is the value for steady flow. So for steady flow, and for steady flow this value is 0, means L for steady flow. Now here for steady flow, this point is very important. For steady flow, this value local acceleration equal to 0, and for uniform flow convective, this velocity with respect to pace is 0. So convective acceleration equal to 0. And for both case, for steady and uniform flow, acceleration is 0. Acceleration of fluid particle equal to 0. Understand? These 3 points very important for any kind of exam. And this is the total acceleration. Total acceleration is convective acceleration plus, so this is total. You will write here total acceleration. Next is general form of continuity equation. In 3 dimension. First consider a fluid element. This is the fluid elements. is x, y, z. Suppose this is the fluid element A, B, C, D, and this is the phase, and E, F, G, H. This is the another phase. Consider whose this length is dx in x direction. This is the dy. Consider a fluid element length of dx comma dy and dz in x comma y and z direction and let u, v and w are inlet velocity component in x, y and z direction respectively. Understands? And mass flow rate. First, mass flow rate equal to density of fluids into area of cross section in flow direction into velocity in the direction of flow. Velocity means rho area into velocity, velocity in the direction of flow. These points are very essential, most direction. Now, and from the conservation of mass, mass is neither created nor destroyed. So m dot in, mass flow rate in, and m out equal to m mass flow rate stored. This is the conservation of mass, and from this equation we can easily get the continuity equation. Now, mass flow rate of fluid, mass flow rate of fluid entering in ABCD phase, entering the phase ABCD equal to m dot x. This is entering m dot x, and this is the leaving m dot x. And mass flow rate leaving m x plus, this is the Taylor series equation, mx into dx. This is the mass flow leaving, mass flow rate leaving, mass flow rate of fluid leaving in the phase EFGH. Understand? Now mass flow rate in minus mass flow rate out into x direction equal to in m dot x minus this one, and this one is this minus this one, so minus this also minus sign, x into dx. Understand? This one cancel out, so minus d, and mass flow rate already I know, rho into area of cross section, rho, this is the density of fluid, and area is this one and this one, and dy into dy area, this is the cross section area, this flow, dy into dz into velocity of the direction. This velocity, suppose this is in u, v and w, and this direction is u into dx, Understand? In similar, now write this one. Now this one is x direction, m in similar, m out in y direction equal to minus d rho into dy. So first calculate d into rho u into dx by dx into dy into dz. You can write, and this is the and this is the, this one is volume dv. You can dv, this is dv equal to dx into dy into dz of these elements. So we can write d by dx dy, this is the y direction, rho into, suppose this is dv and this is d volume, into this y direction flow is v. Understand? And m in, m out, z direction, d by dz rho into dv into and this is the total sum, this is the gain of masses, this called gain of masses in x direction, net gain of mass, this is the net gain of mass, and gain means store, gain of masses, net gain of masses, this one, and this was sum of this one, this one, this one. So dx into rho and d rho into dv into u plus dy into rho into this is into dz into rho into dv in this net gain. Now so dx into rho u, dx into dx into rho u dy into rho v plus d into dz into rho w into dv common net gain. So m store equal to dm by dt and dm equal to m dm by t. So dt rho into volume, the volume is this element dv. So m store, this right is m store equal to d rho by dt into dv, and this one and this one and this one is equal now. So this value dx by rho u plus dy into rho v dz into rho w equal, and this dv equal to d rho by dt. Oh, this value is negative sign. This is negative sign. Sorry. Net gain. This term will be negative, and this is also negative sign. D rho into dt.